Okay. Good morning, good afternoon, whenever you're watching this, good evening. Um, there's an assignment. Georeferencing is the goal. And you can see behind me, I've got this File Explorer window open, and there's a bunch of different aerial photographs, all black and whites from, well, back in time. And they're all scanned in. They're wonderful, wonderful products that sort of describe the history of Sault Ste. Marie in images. Some of them go back to as far as the 1930s, and what we're going to do is we're going to georeference them. What the assignment is you've got a report component as well as the georeferencing of these images. So the report itself, here's an example. I had a student hand one of these in a while back. I was actually pretty happy with it. And all it is a report that shows a particular air photo. Talks about things like the air photo name. In this case, we've got A27441. That's the roll number for a photograph. And you've got a photo number, and in this case, it's photo number 188. And that was all, that's really important to use because that's how we find all of the metadata for these photos. So part of the assignment is, yeah, we got to do the georeferencing side, but you also have to report on each photo that you georeference. And I need things like altitude, focal length, when the photo was actually acquired, right? So the acquisition date or the end date. You can put other things in there like film type or even photo scale. You could calculate the average scale of the photo if you want based on the focal length and the altitude. And the elevation in Sault Ste. Marie is roughly 750 feet above mean sea level at the St. Mary's River level. And then if you're up above the hill by Sioux College or even up, close to Hiawatha, you can get upwards in the 1100 feet range. And that's really important. Anyhow, in the reporting side as well, you'll see that there were some comparisons drawn between the black and white photo and this particular one in this report. You can see it was captured in 1989. That's quite a few years ago. And what has changed since then? That's kind of the theme of the report. For every photo, you've got to go in there and have a look at different portions of Sault Ste. Marie within the boundaries or the extent of the black and white photo, and kind of flip-flop between the photo date and the and the most recent imagery that we have. And you can see that in this particular report, the student talked about the John Road Center down by the Churchill Plaza area having quite a bit of change. There's a solar farm that went in. You can see subdivisions as examples. There's other photos here. 187, you can see the student talked about the Crimson Ridge Golf Course, changes at the Algoma Steel industrial area, and so on, right? So the report itself requires you to go through 3 different air photos because that's what you got to georeference, 3 air photos, okay? The report is worth a total of 30 marks, okay? You get a total of 10 marks for each photo and the comparisons, okay? So that's something that's important. You get 4 marks for putting a copy of the photo in the image and also referencing where it comes from, citing the website where it comes from. I'll show you where that is in a moment. And then 2 marks each. For each comparison, you get 2 marks. And this is what I'm looking for. This is nice, clear, concise. There's not a lot of extras. And this is right here, this comparison with the photo, this is worth 10 marks, these 2 pages, right? You go here to the next one, there's another 10 marks. This report, even though it's very, very simple, along with the references, it's a 30 out of 30, right? Which is great, okay? So that's what I'm looking for on the reporting side. And then, of course, we have to georeference these photos, and you choose 3 from this shared folder. And you can see there's all different scales of air photos in there, and you can see that there's different portions of Sault Ste. Marie, different coverages, different altitudes, all of that stuff. You choose 3 of the photos, I don't care which, just find 3 that you think are interesting and georeference them. Okay, that's the assignment in a nutshell, and you've got to go to a specific web page. I'm going to go to it right here. You can do a Google search and look for the Earth Observation Data Management System, and it'll bring you to here, and you can search for specific things. Now when you click the search button there, you can see it says you have to be a registered user. No, you don't. You can just say continue searching only, and watch just what my mouse does. Oh, it's reloading. Give it a second. That's because I've been sitting on it for a while. Continue searching only, and then we're looking at the National Air Photo Library. That's where these were actually captured. So you're going to click there, and then you're going to look down here. We don't need to worry about dates, but the data options, we can put in the photo number, the roll number, and what I want each of you to do is to use the roll number, A27441. And then go down to submit search, and you'll see that you can see how many results per search are allowed. I usually bump that up to 1,000. There's never going to be 1,000 photos on a roll, because it's an actual roll of film, right? So there'll be roughly between, as little as 12 and as much as I don't know, a couple hundred. So we hit the search button, and this database, what it's going to do is it's going to bring up all of the different photos, right? And you can see A27441 is, where is it? There's one of them right here. That's one of the photos, A27441, and it's photo number 187. We've got 187 and 188 available. Now, when you look at this data management system, what I want you to do is find the photos, right? If I can just move that over, I can't right now. The photo numbers themselves are listed right here, and I'm going to sort it descending, so I just, so I can find what I need easily. Number 187 is there, and notice that if I click on one, it's going to zoom me right to it. 187 is right here. You're like, okay, well, big whoop, right? Like, who cares? It shows me where the photo is. That's not what I need for georeferencing. Well, it is going to be what you need in order to find some metadata out about the photo, and that's part of the reporting process, right? So I've got 187 clicked there, and you'll see that there is a metadata link here that you can view. It's going to open up another window, and we can look at the metadata for this photo. And you get things like altitude. You can see that, the areas there, that's not really necessary for our purposes unless we were doing multiple cities. But the focal length is a big one. That's roughly 6 inches. The scale is usually in there. Where did it go? There's the scale. 1 to 60,000. I don't believe that this is a 1 to 60,000 photo. I think that that was a mistake, because I can calculate the scale. An altitude of 28,000 feet with a focal length of 6 inches and an elevation of the ground roughly 750 feet. That's more like, I don't know, that's roughly maybe 1 to 40,000, 1 to 35,000. And we can talk about that equation in class. Anyways, this is part of the report. You need to pull in information about where you got this, and you need to put a citation in there for this particular image. And you see it in the report that was brought in. There's some Earth Observation Data Management Systems references there, but each of the photos also, you can see that citation is there. So this is wonderful. This is exactly what I'm expecting for the reporting side. Okay. Now, in ArcGIS, that's where you're going to be working. And I'm going to pause this video and take a moment to get set up, because the next part of this video we're going to be talking about the actual georeferencing of an image. There's a few different ways to do it, and I definitely want to talk about how to be efficient, but also how to not lose any of your data, because georeferencing, you're creating new data by using what are called ground control points. So hang tight. I'm just going to get set up for a minute, and we'll talk about that next. Okay, the report itself is worth 50% of the total grade for this assignment. The assignment itself is worth 60 marks, and 30 of those marks are for the report. We talked about the reporting side, and what's going to be important next is, well, how do you get the other 30 marks? You have to choose 3 photos. Each photo is worth 10 marks. You get 10 marks for georeferencing a photo with a high amount of accuracy. Your grading is going to be based on accuracy, right? You could throw a whole bunch of different tie points or control points in order to match up and align the black and white photos with actual coordinates, but if it's not accurate, you're not going to be able to get a full mark or full marks. Right. The images have been shared out. If you don't know where they are, check your email or open up OneDrive and look to see what folders have been shared with you. Okay, you'll see that there is one folder called NAPL, NAPL. Some people have been calling it NAPL. And in there is a georeferencing folder that has a bunch of images in it, and those images are named based on the roll number and photo number, and that corresponds directly with what you see here. Okay, and I am going to do an example first to show you what a georeferenced photo looks like. Okay, so let's try that. And go back to Arc Pro, and there's a few things that are very important if you're going to be doing georeferencing. And the first one is, well, what are you going to use to align the black and white photo? So what is going to be the source of the coordinates that you're going to assign to locations in the black and white photo, right? Because the black and white photo itself, if I just drag one in, here's 188. If I bring in 27441_188, if I just drag it into the map, I'm going to get a warning up in the top that says unknown, right? The data source is missing coordinate system information, right? And where did it go? Where am I looking? Where is this photo? Why isn't it just showing up in Sault Ste. Marie? Well, it's not, because it all depends on what coordinate system your map is currently in. Because the black and white photo doesn't have a coordinate system yet assigned to the pixels that are in it, what ArcGIS Pro does is it just throws it down in the bottom left-hand corner of whatever coordinate system you're using. It goes to 0, 0, basically. 0x and 0y. And let's even prove it. If I right-click on this image and say zoom to layer, it's going to bring me to this image, and you'll see that it's, well, where is it? Well, you can look at the coordinates at the bottom of my page right here. If you follow my cursor, you can see that if I go to the bottom left-hand corner of this image, I'm at 0, 0. Well, what is that? What is 0, 0? Well, I'll tell you what 0, 0 is. It's directly corresponding with the coordinate system of the map that this image has been pulled into. And if you look, we've got a map here, and the world imagery layer is showing that we're in WGS84 Web Mercator. That's what the base map is in, okay? But we're not going to use that. We're going to georeference this black and white photo using the most accurate datum that we can use. And in fact, what's going to be used is NAD83 UTM16N. We use NAD83 UTM16N whenever we're going out to the field with GPS units. It's accurate, right? It's a projected coordinate system, and I'll show you that the map, that I've set the map to that coordinate system. If I go to the map properties, you'll see that currently the map is in NAD83 UTM zone 16. Why is that important? Well, you'll see that everything lines up. If I zoom way out, you'll see that everything is lined up perfectly down the center for the UTM zone that Sault Ste. Marie falls within, right? So in a north-south direction, 0 for NAD83 UTM zone 16 is the equator. But what about the east-west direction? Where is 0? Well, that's going to be dependent on UTM zone boundary. Okay, and you'll see that Sault Ste. Marie in real world NAD83 UTM zone 16 coordinates, you'll see that Sault Ste. Marie is roughly 700,000 meters eastward from the UTM 16 boundary. So we're actually almost in UTM 17. And Sault Ste. Marie is roughly 5,150,000 meters north of the equator. Okay, if I zoom back to this black and white photo, we're sitting at 0, 0. So you can see that, you know, where it's located compared to where Sault Ste. Marie is, two completely different places, and we've got to get the photo there. Simple, right? Well, there's a lot of different ways to do it. I can zoom to Sault Ste. Marie in a lot of different ways too. Here's an interesting one on the map. I can open up a locate and I can say Sault Ste. Marie, right, Ontario, Canada, and I can zoom there and get there very quickly, right, instead of trying to use manual zoom tools. That's always fun to do, and so on. But how do I get this A27441 image to sit and to float in front of Sault Ste. Marie so that I can start to pin down, just like putting a poster on the wall, the coordinates of this black and white photo to this area? Well, it's called georeferencing, and it's basically we're co-registering the black and white photo with something that has coordinates that we can match up locations, right? So this is what you do. You click on this image here, and then up top on the ribbon there's the imagery menu. If you click on the imagery menu, you're going to see that there's a lot of different functions that are available. And the one that we want is called georeference. As soon as you click on the georeferencing button, all of a sudden you're able to see that, oh, now there's all these different tools. Well, what do these tools mean? Well, there's what's called a prepare tool group over here on the left, and you can fit this image to the display. That's not going to make it accurate, but it's going to get it closer. You know, instead of it being way down at the equator, you can fit it to the display. And if I do that right now, you'll see that it will just boop. There it is. My timing was a little off there, but whatever. So now there it is, but of course it's not going to work. I've got to take a coordinate from this black and white photo and assign it to an actual location down here. So let's talk about that, right? I turn this image on and I've got to basically pin and match locations together. Think of it like a game, really. It's really just a matching game, okay? And the question is, well, how do we get this black and white image to do it? Well, we've got to use these tools. Manually, you can use this tool right here called Add Control Points. And I'm going to, while I'm doing this, I'm going to start adding control points, but I'm also going to talk about the requirements for control points. What's a good control point? What's a bad control point? Okay? And there's also a really important factor here where there's an order of operations. For each link, think of it like a stitch, right? And you've got to start with the black and white and then connect it to a coordinate. And all of these things are going to go into what's called a table, and you'll see that your link table will show coordinates that are actual real-world coordinates in the UTM16 projection, but there's also these photo coordinates, right? And they are just pixel locations in the photo. So we got to tie these pixels in this photo to real-world locations. I'm going to start down in the bottom corner, and you can see that I'm just sort of slowly zooming in and looking for things that can be used. Now, in class, we'll talk about all the different, we'll talk about topographic displacement, we'll talk about radial distortion, we'll talk about how the curvature of the lens causes things on the outer edges of these photographs, being frame camera photographs, to bend outwards. So you can kind of see the side of the International Bridge because it's high up above the ground and it's also far away from the photo center. That's distortion that we have to deal with. What a good ground control point. There'd be a beautiful one right here. See how you've got this nice pointy end of this pier? This is a concrete pier. It has not been modified. So what makes a good control point? Well, there's a few different things. Number one, it's at ground level. It's not a 3-story building. You know, because of lens distortion and topographic displacement, you want to find things as low down as possible. Rule number one. Rule number two, it has to be something that's verifiable in your black and white photo and your more current base map, or maybe you've got an ortho that you're using, right? This add control points button, if I click on it, it's going to allow me to be accurate, right? You can see that it's showing the from, meaning it's got to go from here to there, right? The bad has to get turned into the good. Bad to good, from to. That's the order of operations. So when it says from, you left click on the black and white photo. Now I'm going to actually try to get this perfectly at this point right here, right at the edge. And this is going to be accurate in 2 directions, north, south, and east, west. As soon as I left click, all of a sudden now what it's looking for is the 2. I'm going to zoom out and I remember what I did. This is the same area that I've got to look for. And notice that you can still navigate, you can still zoom in and zoom out, and your stitch is still there. It's just not completed yet. Now, you can also turn off the black and white photo, and this is actually good practice. Turn off the black and white photo to see that you've got to go and find that same pier. Well, where is it? Way over here. Where did it go? It's this one right here, isn't it? See how it's got a nice point? As soon as I add this, it's going to stitch these two together and pull it nice and tight. I've left clicked again and you can see that now it's put that there. Now if I turn the photo back on, it will auto adjust to show that now these two locations line up. But the problem is that that's just one stitch. This photo is going to require quite a few stitches. My second stitch, or my second ground, at ground level, control point needs to be something else. Now, don't put it right beside this one. You've got to go way over and find something up on the edges at the north end, or over on the south side, or way over on the east side. The further away you are from your first ground control point, the better when you're setting your second ground control point, because this is going to set the scale of the image, and it's also going to put you on a good path to accuracy, okay? Now, what I mean by that is, you might be like, oh, there's a big X right there, and if I turn it off, is the X still there? Oh, it's not still there. Well, you might be able to find it, so it's going to be difficult. You have to find something that is verifiable in both images, okay? And what I do know is that there are some intersections that can be used, but don't just eyeball the center of the intersection. Find a nice, crisp corner of something, preferably something like that's concrete, that has not changed. That's really important, because if you do that, you will be much more accurate compared to if you were just kind of estimating or shooting from the hip or whatever, right? So let's think about that as we work. Now there's the Hiawatha area. I'm going to go way up there, and there's what looks to be a building right here. I think it's the fish hatcheries building. So you've got this nice L shape. I'm going to use that, and I'm going to go right in the corner here. Now this building is not very tall, so I'm not really too worried about topographic displacement. If it was a 10-story building and it was bending outwards from the center, it would not be a good idea to use that, because you would have to find the bottom corner of the building where the building attaches to the ground, and then you can use it. as verifiable, as a nice corner. I'm going to use this one right here. There's my from. Now I've got to go and find this same building. And I know where it is. It's roughly in the Hiawatha area. Oh, there it is. Nice and bright, and there's the L shape. There it is. So notice that I'm zooming in close enough. I'm right now trying to be accurate to within the nearest meter if I can. That'd be lovely, right? So let's put it there. Turn the image back on, and this is going to handle the scale and the rotation, and we're going to start to see that the images line up roughly. With 2 ground control points, all of a sudden you're just like, I'm off to the races, right? It's just, things are not going to be perfect, and the further you are from any existing ground control points, the more inaccuracies there are going to be. So think about that. This image itself would take roughly, I don't know, as many as probably 30 GCPs to tie it down. And how do I know that? Well, I can go into an area right here where, you'd think it's lining up nice, and it's pretty close, but if you see me toggling the image on and off, you're going to sense that there are some shift directions happening. Okay, so I'm going to turn off the video capture here, or my video capture there, so you can actually see my whole screen. You can still hear me. So if I turn this on and I turn it off, you can kind of sense that there's a bit of a shift happening, and there's also things that have changed, so you got to really be careful about that sort of stuff. There are different ways to do that. I can turn on this image here, make sure that it's selected in my contents pane, and I could also click on the raster layer up top and use a swipe feature to sort of see if I can find out where the shift is happening. Right? That's a nice feature to use, so that you can also decide where there are going to be decent ground control point locations. And remember, I said concrete or permanent structures that have not changed, and corners, something that can be verifiable in both the east-west or the north-south direction, and the north-south direction. Right? So let's go find something else. Doing the center of an intersection is not a good idea. Sometimes you can find other things. Like here's a circle area. I think it's called a cul-de-sac. And this area is small enough to try to maybe hit a bullseye right in the center, and that allows you to be relatively accurate. So that's going to be what my next control point is. And remember, you go to Imagery and Georeference in order to open up the georeference tools. Okay, the Add Control Point button is right there. We're going to add this, sort of try to hit the center of that circle. I turn off the image, and we'll see how far the image is still out. See that? That belongs way over here. I'm still trying to be within a meter accuracy. If I do that, that's my third control point, and watch. It lines it up. It pulls it into alignment. And now in this area, we're pretty accurate. Now we're starting to see some improvements in the accuracy. Okay? You can continuously do that, but before you get too far ahead of yourself, how do you save your progress? Like imagine if something happened, or if you hit a key in ArcMap or ArcGIS Pro were to crash, or if there was an issue and you had to leave and you just closed the project without saving things, you'd lose that. You'd lose your 3 georeferenced points. We don't want to do that. So if you look here, you've got a control point table, and I want to open it. And this is going to show that right now there are 3 control points that are being used. Right? You can deactivate them, and you can enable them based on accuracy. Sometimes you do a GCP And if it's not as accurate as you'd like, you can go in and see whether or not a GCP is a valuable addition to your work, right? Right now my residual error is relatively low because I don't have very many ground control points, and I've been using and selecting good control points. We need to export these out. I want to export out all the enabled points. I use this export control points, and this is number 188. You'll notice that I've already saved a control point table here, and I'm actually going to show you that, and that's what this is. It's a text file. It's an exported control point table that has a bunch of GCPs in it. And I'm actually going to use that as an example to sort of jump ahead and show you what a completed georeferenced photo should look like, and talk about some options after that. So I put the first three in, and you would continue to do that until you got to a point where you are completed. So I'm just going to give this a weird name right now and say there it is, and save it out, and you'll see that once that's done, once that is done, you can actually remove the photo and add it back in. Notice that when you remove the photo, the georeferencing goes away. Well, if I bring that photo back in, I have a couple of options, right? I can go back to georeference and I can import control points, right? Sorry, that's me grading. If I refresh this, you'll see that I saved this table at the last time. There it is. If you bring that in, it'll put you right where you had left off. That's an important thing for each of you. You have the opportunity to save your progress. So those 3 points are good. I save them, right? Now I'm going to actually I'm going to import different control points. I'm going to import ones that I had saved out and move to here. And now you'll see that right now I have all of these control points in, and if I open up this control point table, you'll see that there are now, how many do we have? We have 49. Now that's, I georeferenced this image. I can't remember when I did it, but it took, I don't know, about an hour. Maybe not even, I can't even remember. It didn't take as long as you would think, because as you're lining it up, all you're doing is you're just continuously looking for any shift. And each control point is going to have a certain amount of accuracy associated with it. Because there are undulations in topography and all of that, you have to push and pull the pixels around so that they fit properly. And what that's called is you're transforming the image. You're transforming the image by resampling these pixels and making sure that they are in the correct locations. And the transformation that's set right now is what's called a first order. It's kind of like the weakest. All it can really do is rotate and shift and move around the image without pushing and pulling the pixels around too much, right? And if you look at the transformation drop-down menu, when you're using a first order, you need at least 3. Pardon me. Right, I was talking about, sorry about that, I was talking about first order transformations being kind of like your introductory transformation, right? You need a minimum of 3 control points in order to have a first order transformation. But as you move upwards in these transformation levels, the software has more of an ability to stretch these pixels out and modify them and really put things into place, right? And it's a relative thing, right? If you're doing a georeferenced image that's in Saskatchewan where there's like 0 change in elevation, where everything is at the exact same elevation, that means that the scale of the image is going to be exactly perfect. right? When you've got, in this case, in Sault Ste. Marie, right, we've got different elevations all over the place. The elevation in Hiawatha is like almost 1,200 feet, and then you go down to St. Mary's River and you're down to 750 feet, and all of that is within the same image. So think of it like you're putting a blanket over top of everything. It's like there's going to be different undulations, and all of those pixels have to be spread out or put closer together in order to accommodate for topographic change. And that's what these different transformations are able to do. The best we can do is to do what's called a spline. That's where you've got a lot of topographic change to deal with. But as you move through transformations, you'll see that what actually is happening is, here's a case where we've got Fort Creek. I just zoomed into Fort Creek, and you can see that there's a green and a red. And what the red is, and this is a good ground control point where we've got this little island, and the red is the from, the green is the to, right? So that same island is seen in both photographs, or both images, right? But we need this link to be pulled closer together. So we need it to we need the imagery to be transformed so that that link gets pulled tight. Think of it like pulling a stitch tight together. A first order transformation has limitations. When you go to second order, watch, the link gets closer together, right? So the differences in locations get more, the precision goes up, right? And the accuracy goes up, but there still is, it's not pulled tight yet. Now the transformation on a second order needs a minimum of 6. We can go to third order, that should pull it even tighter. Oh, but it all depends, right? So at third order, we're actually still not pulling it completely tight. There is one transformation that, you know, if you have an area with a lot of different topography, use a spline. That's going to pull all your coordinates tight to each other. Your GCPs will be super tight. There'll be no shift at all, and the imagery should line up perfect. Of course, a spline can also cause a lot of different issues, where if you have a bad GCP, like if you've messed something up where you didn't get the location matching correct, and I'll show you, maybe I can do it here. If I accidentally say this belongs way over here, watch what happens to the image. It may actually take a minute for it to work, but it's going to cause distortions. And the only way to really fix that is to get rid of that point. You can highlight a point and delete it. See the distortion that it was created, and after I delete it, it comes back to normal. I'll even show you again. If I go here and then I say that it belongs way over here, what's going to happen is it's pulling that image out of alignment. A spline allows you to do that, but of course it's also, it can be really, really bad. So I've made a bad point on purpose there, and of course you can use the table and select that point and delete it and get rid of it, and then the accuracy comes back. Okay, that's an important part of this as well. This control point table is helpful, and you can see that this image here has been georeferenced. And how accurate is it? Well, let's go have a look. Let's see if we need any GCPs. How am I going to be evaluating this? I'm going to go into an area like this where I don't see any GCPs at all. That doesn't mean that it's not accurate. It just means that there aren't any GCPs needed here because the alignment is good. So students quite often get confused about, oh, I need, how many GCPs does this need? It needs as many as it needs. If the image is inaccurate, or if the alignment is off, you've got to use GCPs to line up the images. And some students say, well, what's the minimum number of GCPs that I need to use? I don't know. It all depends on how accurate each of the GCPs use are how much topography there is in the image and where you place these things. Have a look at the placement of these GCPs. Do you see very many clusters? There's you can see that there are some clusters happening down here, and there's a cluster over here, but none of them are like right beside each other. They're all spatially distributed equally, but there are some gaps in this image. There's this area here, and is it accurate? It may not be. I'm going to actually go there because it's tempting for me to go and find a place that doesn't line up, and that's how it works, right? Let's go see if this area right here is lined up. This looks to be like there are some buildings, and this looks like it's Black Road. Let's see what we've got here. On the raster layer, I'm going to use a swipe tool just to kind of have a look and see what's going on. That doesn't look too bad. There are some buildings that are the same, and it appears to me that we could probably put a GCP in. If you're being evaluated and I see something like this and I see this building right here, there is a little bit of shift on this building, and it hasn't been moved. Or I'm assuming that it hasn't been moved. So, you know, evaluate your own work and say, oh, well, no, I need to put a GCP here. If I put a GCP on this corner and I look, oh yeah, it's not that far out. It's only like maybe 10 meters. But if I put that in, turn the image back on, that should help the alignment. Okay. That should help to bring this area into better alignment. If it makes it worse, get rid of the GCP, right? Only add a GCP if it's going to be helpful. Okay, so there are areas here where I don't have any other GCPs. And what does the alignment look like? It looks like there might be a little bit of a shift right here. And how do we fix that? You add GCPs. Right? So is there driveways here that we can use? What can we use here? Probably use the corner of this building here. It's not super tall, but notice that I'm trying to just shoot for the bottom corner if I can. Maybe I'll use this corner. Okay, and how far out are we? Oh, we're not too bad at all. Not a lot of change there. Not to worry. I actually think that it's looking pretty good, right? And that's what we want. We want it to line up nicely. We want to see that all of the streets line up, all of the buildings that are the same line up, right? And that's that. Now, as far as adding comparisons goes, there are lots of different areas that have changed. Like, I'm waiting for students to find, you know, some interesting ones. Like, here's a drive-in theater that we used to have in the Sioux, right here. And now, what is it? Meh. I think it was cooler that it was a drive-in theater, to be honest, but it'll be missed. I don't know what stores are there now, but it's all, you know, retail outlets and so on. So some interesting things to look into the past and georeference these photos. Okay, so how are you handing this thing in? Well, this is a control point table, right? On LMS, there are going to be 3 control point tables as part of your submission. Each control point table will have all the GCPs that you have created to line up each of the black and white photos. Each of the GCP tables has to be named based on the roll number, the photo number, your initials, and whatever you can say GCPs after if you want. It needs to be named accordingly, because how am I going to mark this thing? I'm going to bring your GCP table into ArcGIS Pro, and I'm going to evaluate every single point. How would I do that? Well, here's your link table, right? Let's just say I'm starting fresh and I'm grading and I'm saying, all right, well, here's link number 4. And the reason why it's number 4 is because links 1, 2, and 3 were deleted, right? I'm going to double click, and that's going to zoom me directly to link number 4. And I'm going to evaluate the accuracy of that link, right? So here's the very first link, here's the next link, and if it's a poor choice, I'm going to see if there's any shift happening, right? I'll see, well, do these things not line up? Yeah, that's good. That's a good point, right? So that's how you're going to be evaluated, and there'll be comments made that are directly corresponding with the links that are in your tables. So if there are issues, you know exactly which GCP is causing the issue. Okay, that's it. So 3 link tables, and then you also need to submit a report where you give me a screenshot of what the air photo looks like. You give me the citations, the references, and then I want you to compare what's happening, right? So this is a good comparison right here, and you can see that they're talking about the John Rhodes building, how it was added on to, and so on and so forth. So I need a description of what you see. Okay, that's the report. The report's worth 30 marks, and then each of the GCP link tables are worth 10 marks each. So the total evaluation for this assignment is 60 points. That's it. All right. If you have any questions, please get a hold of me, and this is going to be available for those of you that need help out of class. I hope it's helpful, and let me know if you want any additions to it or if you need any other demonstrations. All right. Thank you. All for now.